A little bit. Now, on this one, remember, we're going to divide up, so far, our approaches to solving quadratic equations. We've got normal quadratic, well, I wouldn't say normal. We've got the kind where we've got x squared terms and x terms, where we've got to just factor them. We've got to put it in standard form, get them set equal to 0, factor them, and then set the factors equal to 0. Those are the hard kind. Then we've got these kind, which are much easier. If there's a situation where we can point to a single x, we can isolate it, right? Just by reversing order of operations. So we can do that here. These are, when you see these, you just rejoice, because you know that it's going to be simple. You don't have to do any complicated factoring. All we have to do is just the stuff we normally would do. Reverse order of operations. What do we do first in this case? If we're going to work backwards.
Subtract 7.
Perfect. So first we subtract 7 and get that, right? Okay. Now what? Divide by 2. Good. So we've worked our way up to the second layer. Now what? Okay, good. Now here's the part, here's the new step. This is the part where you got to be careful, because this is new territory and there's an easy mistake we can make. When I square root, what do I have to do? There's a red flag that goes with square rooting both sides. Say it again. Plus or minus. Perfect. That's going to give us a plus or minus in our answers, right? Okay. And then finally, last step, add 3. Okay. And remember that when we've got a plus or minus in our answers, the most convenient way to add or subtract from both sides, subtracting just adding a negative, is to put the number in front of the plus or minus. So we just end up with 3 plus or minus the square root of 20. Those are our two answers. Okay, now there's one issue that we need to address, because we're starting, when we do problems like this, we're going to get square roots in our answers, and so we want to simplify those. Okay? Square root of 20 is an exact answer, but when we simplify square roots, we like to get as much of that number that's inside the radical out of the radical. Okay, so do you remember how we do that? The way we get stuff out of a radical is we want to try to find the biggest perfect square factor of the number in the radical, so 20 in this case. So it'd be 4, wouldn't it? Good. Now let's quickly review our perfect squares. What are our perfect squares? So we get 1 squared is 1. We don't care about that one. 2 squared is 4. What's the next one? 9. 4 squared, 16.
36. 49.
9 squared. 10 squared. What's 11 squared?
121.
Okay, good. What's 12 squared?
144.
What's 13 squared?
156.
No. 169. Good. And
I don't know this one.
225.
good. And that's probably good. Once you get up to, I mean, that's pretty far. If you know them up to 15, what's 20 squared? 400. Okay. If you know up through 15, that's really handy.
I don't know 17.
What's that?
I don't know what 17 is.
I don't either. But once you get that big, once you use them a little bit, your intuition, if you guessed, you'd probably be right. But once you get up to 225, that's big enough. Okay, so we want to find the biggest perfect square that divides into 20. This one's pretty obvious. It's a 4, right? So if we want to simplify then, the square root of 20, here's how we do this. We just want to break it up into square root of 4 times square root of 5,
It's 2 radical.
which is 2 radical 5. I always put the square root of the perfect square first because that's the one that's going to become an integer. Right? So we end up with 2 square root of 5. Okay? For our, for that part of it. So we'd break this up into a 2 square root of 5. Now in Moodle, how do we do square roots again? Squared. Squared, yeah. Okay? Make sense?
Yep.
Okay.
SQ.
Now, what do we do? Okay, while we're on the subject, what do we do if we want to simplify something like this? What if we've got the square root of, say, 2/5? Remember how to do this. This is not a bad idea for us to review this a little bit now because when we get into chapter 7, we're going to have to look at all this stuff for higher order roots. And that gets, if we don't really know this stuff well, that gets pretty confusing. Okay. So here's what we do with something like this. Let me just remind you how this works. When we're taking a square root, or any radical for that matter, of a fraction like this, we're going to split it up into the square root of the top and the square root of the bottom. Now first, we'll simplify this if we can. If that were something like 4/12, simplify it. Reduce the fraction before you do anything. But we can't reduce 2/5. So we'll make it the square root of 2 over the square root of 5. Now the rule is, when we're dealing with radicals, we don't want to have square roots in the bottom. Kind of a silly rule, frankly. It goes back to sort of an archaic day when we did things a little differently in math. There's really nothing wrong with having a radical in the bottom. But every textbook in the world that you use between now and, say, college graduation is going to disagree with that statement. So you're going to have to do this. We have to get rid of that radical in the bottom. Sure. Just pause this. Hang on. Back to business. So we got to get rid of the radical in the bottom. Now, how do we get rid of a radical in the bottom? How am I going to get rid of the square root of 5? Keeping in mind that just like when we're trying to get common denominators, same kind of thinking. The only thing we really could do here is add 0, which we wouldn't do, or multiply by 1, meaning multiply the top and the bottom by the same thing. Now, you always want to start with the part that you need to change. On the bottom, I need this. I'm going to multiply. I'm going to multiply by something to get a 5 on the bottom in this case. I'm going to unlock the 5 from the radical. How do I do that? I'm going to, I multiply by not 5. If I multiply 5 times the square root of 5, I'm going to get 5 radical 5. Square root of 5. That's it, right? If I multiply the bottom by the square root of 5, that works out. Because the square root of 5 times the square root of 5 is 5, right? It would be the square root of 25, which is 5. But think of it this way. The square root of 5 times the square root of 5 is the square root of 5 squared. That's maybe an easier way to think about that. And squaring undoes square rooting, right? They're inverse processes. So, does that make sense? Everybody okay with that idea?
Yeah.
We got to treat the top the same way, though, right? And so what do we end up with on the top? If I multiply the square root of 2 times the square root of 5? Yeah, square root of 10. Okay. Does that make sense?
Yep.
Okay. So that's how we deal with getting rid of radicals in the bottom. All right, so last issue then. Last thing I want to show you. I feel bad that I didn't. We covered the difference of squares pattern, which is important. If you ever see, let's quick reminder. What if you want to factor something like this? Say we've got 121 x squared minus 81. Okay, now notice the x term is missing, and it's a difference, right? It's a difference of 2 terms. If I can write those terms as squares, then this one is done, because it follows the pattern. A squared minus b squared. And how does that always factor? The difference of squares pattern.
A squared, A minus B, A plus B and A minus B.
That's it. It's A plus b and A minus b. Okay? So if I can write this as something squared minus something squared, it's already factored, right? Just by that pattern. Now, what squared is 81? 9. What quantity squared is going to give me
11.
this result? The number part is 11, and I need an x in there too, right? Make sense?
Yep.
Okay, so this would just equal 11x plus 9
And then
times 11x minus 9.